forgot to raise their hand? See, you're still shooting me instead of shooting them. We should.
Oh, okay.
Let's try that again. Who says the one on the left is an investment? Who says the one on the left is a loan? So you guys changed your vote on that one, didn't you? You guys did. All right, think about it this way. When you're trying to figure out if these guys were loans, one of the things that we said you can do is you just add up the series. And if these things add up to a positive number, it's an investment. And if these things add up to a negative number, like this one, it's a loan. So you guys got that idea, right? Now, if you think about it, what you're doing when you're adding them up, you're saying, well, what happens when the interest rate is 0? What happens on the diagram on the left when the interest rate is 0? Do you end up with a positive number or a negative number? Positive number, which means these things add up to something that's greater than 0. So, is the one on the left an investment? Raise your hand. Is the one on the left a loan? Raise your hand. And you guys still think it's a loan? It's clearly an investment. We'll look at it this way. The diagram for that one right there, as I go ahead and flash this up, you can just go for similarity on that one. Do you see it downward sloping like that? And we decided that that was asset A, correct? And asset A was an investment. And it's very similar to the diagram that we have over there, except the intercept is different. Now let's see what happens. Raise your hand if you think it's an investment. Now raise your hand if you still think it's a loan. And you had your hand up for a totally different reason, so go ahead.
It's just like the part where I was thinking it was a loan is that it starts as a high, like you start by getting money.
No. What you're doing is you're adding up all the cash together. And it turns out that if you pretend time doesn't exist, you get money in that. And so it's actually things like, see asset A over there? Cost you 20, get you 21. So if you add them together, you end up with a net of 1. That's an investment. That's how you can tell. Loans are things which cost you more money than what you borrow. So remember, you take out a car loan, you always got to pay twice what you borrow. Does that work? All right. So now that we see this guy right here as being an investment, I'm going to use color. And we'll see this one over here as a loan. Now let's go through the graphical story that we have for this. Now, in each case, the internal rate of return is right here. The internal rate of return is, as we've shown here, the interest rate that makes the present worth 0. And so there's the 0 on the present worth. So, again, what you're doing with the internal rate of return is basically refunding. And I'm going to stick a couple of them over there. There was a so. Go ahead.
So
see, you should shoot him when it comes to questions.
So if we push our time horizon out, that's going to push the internal rate of return out as well? That intersection?
Don't mess with that. Do you want to have a singleton and push it on out?
I want to know what's going to affect the way that graph looks.
It's basically just a polynomial is the one that's there. If you add more elements to the polynomial, it'll of course change what the graph looks like. And that's what it is. You're just looking at those. What am I looking for here? The coefficients of the polynomial.
Okay.
So you alter those things and you'll end up with a different looking graph. So let's go ahead and say if you have a minimum acceptable rate of return, which is less than the internal rate of return here, and a minimum acceptable rate of return, which is less than the internal rate of return here. So these are identical internal rates of return. These are identical minimum acceptable rates of return. Which asset do you buy? Do you buy the one on the left? Raise your hand. With that minimum acceptable rate of return? Or do you buy the one on the right? Raise your hand. All right, who forgot to raise their hand again? Lots of you.
I chose not to.
All right, I chose not to. Choosing not to vote again. All right, look at this one right here that says investment. Here's a minimum acceptable rate of return. Go up to this present worth function is what it is. You bumped into it, make a left, positive number or negative number? You see a positive number on present worth, you're supposed to buy it?
Yes.
Yeah, so you do get this one right here, okay? So this is a good idea. How about this one over here? We end up with negative number, positive number. Negative. Are you supposed to get things that have negative present worth?
No.
You don't get it.
So is that because it's a bad loan?
Yeah, it's a bad loan. If you think about it, this is the interest rate on the loan. Something like, say, 13.3%. and this is the present worth is 10. Kind of like that example right over there. Man.
So if it were a good loan, the MAR would be to the right of the internal rate of return?
You mean like that?
Yeah.
That would be correct.
Okay.
So this would be something along the lines of, here's the minimum acceptable rate of return, 10. Here's the internal rate of return of 0.05. Now do you see that as a loan that you want to take?
Yes.
Okay. How many of you are now feeling much more comfortable about this internal rate of return criteria? You're feeling a whole lot better about it? All right, that's what we were aiming for. We wanted to have this freedom about it.
I'm still not really comfortable with the lines in the graphs. Like, I understand that it's starting as a positive present worth means that it's an investment because you gain that money. Why, when you graph it, is it slanted?
It's
Is that a weird question?
It's not a weird question. It's just that as the interest rate, you got this benefit that's in the future, and as the interest rate increases, the way that you picture that future benefit from time period 0, it gets smaller and smaller and smaller. So the benefit is huge when the interest rate is 1%. But the way that you view the benefit when the interest rate goes up to 10 is it's not worth all that much. As the interest rate goes up to 100%, that thing in the future becomes worth less, and so on down the line. Now, there was a hand up over here that will give you, sir. You're good right now? What about you, sir?
Can you have the equation for this graph?
Can I have the what?
Equation?
I don't really need an equation for this one. It's just a monotone graph. Actually, we can make something
Because
called...
I don't understand why you have the graph in the right, when the rate increase and the
I'll make one that looks just like this. And after I do this, we'll go ahead and take a break. So all I'm going to do is take this thing that we already did, and we want to have a loan. So now you see this as, that equation up there says, I got $20 in time period 0, and then I had to pay 21 back the next time period. So when we plot this guy right here, there we go, it makes a diagram. And so that's essentially what we're looking at right there. We're getting there now? Okay. So we will continue this quiz, as you guys have been staring this little puppy down, after the break. And what we'll do after the break is that internal rate of return exclusive choice criteria, the one that you never do in the real world. The one that is only for the care of feeding engineers, okay? Or people that might accidentally time travel to the 1930s. That's the other place you may use it. Does anyone have this strange fear? Oh, no. I want to go to 1930s.
Yeah, maybe the 20s would be better.
Not so much. I like my iPhone. All right, so we'll see you in 10 minutes. So we'll reconvene at 3 after.